I think it's a huge challenge to give good quality connectivity, whether that's for basic voice and messaging, but also more importantly internet access in a lot of parts of the world for a number of reasons. And some of those are economic. You simply don't have the ability to fund the rollout of networks in all of those places. Historically, for large telecom operators, it doesn't always fit their model. There's sometimes topological challenges. You've got islands, you've got mountains, and so on. But there's also often sort of regulatory and societal difficulties that mean that not everyone who, in theory, could have access can get to it because they're either too far from connectivity or it's too expensive. So there's at least two separate problems there's the access to having a network at all and then actually being able to afford to use it. And you tend to find a lot of people who maybe have a smartphone but are reluctant to use data services and internet connectivity, except maybe in very, very small amounts.
So we've essentially seen that there's an upwell from grassroots level within a cooperative model. In other words, a very distributed, it's not a centralized, there isn't a single owner, it's the community as a whole that owns an infrastructure. And the second thing you see is that there's a technology that matches the cooperative model, which is this mesh networking, which is a decentralized telecommunications topology, as opposed to a hierarchical topology that's being given from a central provider.
There is a mix, and I think one of the things we're going to see is a sort of a fairly good portfolio of alternatives. Some of them will be decentralized mesh. You may well find a neutral host cellular using low-cost components. There are a lot of possibilities here, and a lot of it's going to come down to a number of criteria on a case-by-case as to what is available for backhaul, what are the actual amounts that the people are willing to spend, is there a local organizer or local business or a local group that steps up for this, what are the relationships with outside service providers for roaming or interconnect, or is there a regulatory side to it? So I think that you will find that in some cases you will have one solution, in other places you will have another, and over time that may fluctuate depending on the situation and how the technology and the prices evolve.
So now let's talk about our box, which I think what everybody wants to talk about. Dean, do you want to do the honors?
All right, let me pick this up. Okay. But this is one of the first times I've seen this in the metal. It's quite well constructed.
Of course.
It's multiple separate units, which are they magnetically connected?
Yep. I've done this one before, and I nearly destroyed my keyboard. But yes, it doesn't quite cling all the way, but it's magnetically connected, and the various platters can come apart. Now this is still a prototype unit, so we haven't built it out with all the features yet, but that gives you an idea as to the product construction. So this is for the moment the Wi-Fi component. Okay, so the idea is to have the Wi-Fi and eventually all the wireless bits sticking in the top. For the moment, until we have our chip development completed, which is about a 12-month period, this will be the Wi-Fi unit. Okay.
Right. And there's the antenna goes.
So you've got all the connectors at the back for that. So you've got Ethernet and some other connectors and USB and so forth. Now, the idea of having multiple platters really comes about because the device itself becomes a platform for innovation. So the bottom platter is the blockchain, right? This is the blockchain technology that provides essentially the economic underpinnings of this network. So that provides the money, that provides the telecommunications. The stuff in between is where it gets interesting, because that can now be used for other purposes. So we can start building multiple platters with two different things. For example, one of these platters can be a computer, which runs a virtualized environment with Docker running in it, where the owner of this device is able to sell to the network virtual private servers with Docker facilities and so forth, and possibly applications running on those. Another platter might, for instance, be pure solid state drive. So you can have 3 or 4 or 5 terabytes of data on one of these platters, and the same thing. That can be rented out to the wider community. Keep in mind the two things that we're starting off with, blockchain and telecommunications, right? The cryptocurrency, the coin of the realm, telecommunications, the broader connectivity, both in the community and into the internet.
I quite like the way it blends virtualization in terms of software with, if you like, materialization in terms of individual hardware components, because that could essentially mean you'd be able to have a distributed network of, say, edge computing capabilities, but not every node necessarily being equipped with the edge computing facility. It's essentially it's an optional module that could be added on.
That's right. So not everybody will want to have extra solid state drives. Not everybody will want to run a virtualized, containerized server. And some people might even want to run 2 or 3 of them. So it all depends. This thing will obviously not stack up infinitely. You might end up having multiple devices, but it creates a very modular edge computing and true edge computing, edge cloud.
The idea is to get something like a micro data center running at the edge.
That's right. You know, that's far in the future. The initial is obviously the mesh networking and making all of that work. What our designers have been doing is looking at taking those technologies and squashing them into a single chip, which creates a number of opportunities. Number one is it uses much less power, because now instead of driving 5 or 6 different chips, you're driving one chip. Number two is the heat, obviously, that results from that. The other is the cost. Right. And that's a very, very important thing, because the half of the planet that's not well connected obviously is in emerging markets by and large. And when you talk about emerging markets, the cost of equipment like this is very, very important to people. So bringing that cost down dramatically is, as much as the technical requirement to be able to scale, that is a very, very big driver for us. So having all these different bands with the different protocols, so whether you're talking Wi-Fi, Bluetooth, the IoT bands, LoRa's and so forth, or whether you're going up to the other bands with the unlicensed areas, which is specifically where we focused on, like LTE, unlicensed, unlicensed LTEs, LTEU, right? Having all of that in one device, one can almost think of it as a multi-lane highway, which is a fast spectrum or fast band, but you're pancaking a number of highways on top of each other. And that you, at any point, if you see there's traffic on this layer of the highway, there's an off-ramp somewhere that can take you up or down to a different layer of this highway, that your traffic has options of being able to negotiate where there's less congestion. So it's about this issue of getting around the congestion.
Yeah, but also in terms of resilience, trying to, for example, because most of the Wi-Fi, long range Wi-Fi requires line of sight, right? And if you talk about disasters and other aspects, you could possibly be having something like TV white space, which Ammbr intends to support, can kind of overlay on top of Wi-Fi, long range Wi-Fi at 5 gigahertz, for example. So even if there is an earthquake or anything like that, the TV white space link would still function because it requires an online of sight. It doesn't require a line of sight.
And that's a big part. I mean, you've now got the hurricane in Texas, right? So FEMA is looking at any type of technology that can roll out in disaster areas, and that's true for other parts of the world as well. Bangladesh, we've just had all the floods and so forth.
One of the things that I would say that for people watching this is the term mesh for mesh networking gets used in a lot of different contexts and at a lot of different scales. So at the moment, if you look in the news, a lot of the talk about mesh networks is around just small networks to improve coverage within your house. So Google and Eero and a bunch of other companies are doing in-home meshes, which isn't really what we're looking at the moment.
So the incentive structure in itself is fairly simple. It's a blockchain-based cryptocurrency which can break down to tiny little payments. There's virtually no friction. There's a tiny little transaction fee, which is effectively the mining fee, as people in the crypto community like to call it. But there's a transaction fee that accrues to the owner of infrastructure. So every person that owns one of these things, or whatever other devices eventually come onto the Ammbr network. Okay, so this is not the Ammbr network. This is just the first of many devices from many different companies that will eventually comprise the overall infrastructure of the Ammbr network. So whoever owns the infrastructure, in other words, is the miner. Okay, he's not mining cryptocurrency in the typical Bitcoin sense, as in creating money from fresh air in order to solve the problem. He's being paid a transaction fee to perform particular services. Those services might be telecommunication services, as they are in the beginning, but later on there might be other services. Sure. There might be computing, there may be storage, there may be particular applications.
Sure.
When it comes to applications, for example, that becomes even more interesting. Software can be infrastructure. It doesn't have to be a hardware device.
Sure.
You could be somebody that writes an application that runs on this network, and that application is infrastructure because people use it for some utility, and they will pay you for whatever your software does. When we started the Ammbr design of the blockchain, we said, okay, how do we solve these problems? How do we solve the power problem? How do you solve the decentralization problem? And how do you solve the problem of the expense of becoming a miner on the Ammbr network or joining in this consensus mechanism? So we went out and we got ourselves some fancy technology. Thank goodness for good chip people. We have this silicon germanium chip that we're building. The silicon germanium is a very impressive piece of technology. When transistors were first developed many years ago, germanium was an integral part of that. It was sort of superseded with silicon, so most of the chips that have been built in the last few decades have been silicon based. More recently, some groups like IBM and so forth have gone back into germanium with a bunch of other things that they've been looking at as well, and they've actually found that silicon germanium is an optimal material for building very, very fast chips. So you get I don't know how to pronounce it. It's SIGE, so SIGE or CJ, or depending on where you're from. These chips are used predominantly in telecommunications products today. They haven't traditionally been used in computation type chips. Now we've gone and we've actually built a computation type chip out of this substrate, which runs tremendously fast. It leaves everything in the dust, basically. There's no silicon chip that even comes close to competing with it on speed. It's literally the tortoise and the hare. An Intel 7 or an AMD or even an FPGA or the specialist ASICs that you get in the Bitcoin mining world are the tortoise. This thing that we're building is the hare. It's so tremendously fast. So what we've done is we've replaced the burning of electricity as a financial de-incentivizer, and we've rather replaced it with a velocity. Okay, so the proof of velocity, POV, is how we underpin our blockchain technology. So effectively what we do is the network sends this chip a challenge, and it says to the chip, okay, do this calculation. But it's not a calculation like Bitcoin, a huge computationally intensive thing. It's actually a very small computation. But it's a computation that is broken down, first of all, in a serial fashion. So you do the first bit, and the answer to the first bit gets fed into the second bit, gets fed into the third bit, and so forth, so that you can't parallel process. You can't string a whole bunch of processes together in parallel to try to find the answer. You have to run through it in sequence. So in sequence, our chip performs that calculation in a very short period of time. Okay. You try doing the same computation on a Intel 7, for example, even if it's overclocked, and it's going to take hours. Now what the computation mechanism says, it says, okay, here's your challenge, and it randomly assigns a time. It says, I want that answer in so many milliseconds or so many microseconds. The other chips are out of the race. They'll just never finish the race within that period. But you have now also the additional security of saying, I don't want that answer in 25 microseconds. I want the answer in 17 microseconds. And you have a variance of 2 or 3 microseconds around that if the answer comes back within that period of time, it's okay. The guy's valid as a valid node. He's actually allowed to play. If he doesn't fall within that band, he's disqualified for this round. He can try to participate again in the next round, but in this particular round, he's through the door. So that's roughly how our consensus mechanism works. And the advantage now is you've got a chip that, first of all, costs very little. So you don't have this expensive mining equipment challenge. Anybody can have one of these chips. And in fact, we'll proliferate the chips in order to bring in other equipment manufacturers. We'll allow them to embed these chips. We'll put them in the form of SIM cards, micro SD cards, USB sticks, any shape and form you can think of, to be able to put them in other devices and for those devices to participate within the Ammbr ecosystem. There's obviously a large part of the world where people do have internet. There's a wireless connectivity or mobile phone type connectivity around them, yet they still don't participate in this digital economy of ours.
Yeah. And so, I mean, for some people, there really are hard economic problems in terms of, say, affordability of smartphones or even feature phones. But above that, there's people who perhaps have access to some form of device, either their own or shared, but can't afford internet access, and particularly can't afford regular, ongoing, good internet access. And so there's quite a lot of people who will be very, very restricted in their use, either in terms of, you know, a few hours a day or a certain number of, well, thinking in megabytes rather than gigabytes. And I think also who if you live in Europe or North America or a lot of other developed countries, you're used to having an always-on experience. You're used to having your phone pinging with notifications. You're used to sort of accepting inbound messages on WhatsApp or Facebook or WeChat. And I think that the intermittently connected user have a very, very different experience of the internet. Now, it's still useful, it's still valuable for education, and you can download information. But I think that it doesn't have to be, you know, multi-megabits per second necessarily, although for video streaming that's useful. But I think it's the constant connectivity is not to be underestimated.
Yeah. Right. And another thing is this whole pricing mechanisms of how the developing world or the emerging markets are being priced. Like most of these users are on a pay-as-you-go based model. So when you have a pay-as-you-go model, they are really worried about their data caps and data usage, right? And that kind of hinders how people actually access the internet, right? So basically, by getting something like Ammbr on board, and you are providing connectivity at a significant fraction of the cost, probably, you are getting more users to actually use the network without actually really worrying about the data usage, and that is going to incentivize more and more users to come online, right? And by getting more people online, you're creating a local marketplace, and by enabling this whole edge computing paradigm and providing services that are more catered to local users, you're actually enabling more users to actually use the internet because you're providing content that is more specific and that are catered for.
With the concurrent economic upliftment and economic activity that then generates from that.
And I think that one of the interesting things I see is around that sort of localization of content and application. Sure. There is an emerging grassroots movement around telecom application development. I sometimes go to events run by an organisation called TAD Hack and TAD Summit, which is often developers from developing economies who are looking at local applications and particularly working with infrastructure which allows programmability. And I think that adding, whilst obviously, you know, from an ideal view, a lot of people would like to have free Wi-Fi. But in a lot of places, that's not going to be economically sustainable because the venue will need to pay for their own internet connectivity and backhaul. So some sort of easy, frictionless micropayment model is a particularly interesting approach. And particularly if that's then tied together with applications which might be able to either sponsor data access, perhaps watching adverts or something like that, or a transaction fee, or where there are other mechanisms for multiple stakeholders. It could be aid agencies, it could be the local government, it could be schools, or it could be gifting as well. Yeah. There's a lot of ways in which we can postulate how people can afford to get online more effectively. And at the same time, there's clearly going to be developed in cellular pricing as well. But I think that adding the sort of mesh and decentralized component to that will stop there being the sort of single monoculture of pay-as-you-go
Yeah.
SIM cards and cellular plans.
Yeah, so I would like to actually point out why I'm pretty excited by Ammbr, specifically two reasons. So one is this is an open source initiative, right? The hardware is going to be open, the software is going to be open. So that means you can get any players to come in and build this and be part of the network, right? And we are in this critical junction where major companies in the space, for example, like Facebook and Google, are all spearheading campaigns in terms of building open source equipment, right? Things like Open Cellular has been coming out from the Telecom Infra project. There are other initiatives like Libra Mesh and Libra Router. It's an open source project joined by several community network operators. So they are building technology, and probably we are one of the major.
We're the first to combine.
Yeah, we are blockchain,
yes.
right? So this is going to be it's going to be a major hit.
And we are talking to these other players because
course.
there's nothing to stop them from embedding the blockchain
Exactly.
chips.
Exactly. So
and participating in the economic subsystem
exactly
with their equipment.
Yeah.
That's really what their foundation
So I
is
think
trying
that
to
we have a
stimulate.
very strong unique proposition in the space. So that is one reason. And the second reason is by enabling a decentralized, resilient network with computational capabilities in there, solves one of the biggest problems that we've been talking about is lack of content, right? Because like if you look at sub-Saharan Africa, for example, like most content that is being provided to these places come from outside the continent,
yes.
right? So that means you have increased transit costs, the latencies are extremely high, and there's no lack of local content.
Yep.
And when there's no lack of local...
It's the same old paradigm that you had with mining.
Yeah.
The outsiders come in, mine, take it out, beneficiate
Yeah.
outside, and then import it back in
True.
again at elevated costs.
So when there's no lack of local content,
Yeah.
there are no incentives for users to get online, right? So Ammbr has this unique proposition by building an access infrastructure in a cost-efficient way and making sure that people can get online in a much more cost-effective way, but also providing this whole computational capabilities to build micro data centers at the edge, which means you can now start having local apps and services that can actually run on this network. And once you start having this network, you get more and more users actually start using the network and becoming online, right? And this solves one of the biggest fundamental problems in terms of enabling universal connectivity, right? And I think Ammbr is well positioned to do that.